Picture chatting with a brilliant assistant who forgets your name the instant you look away. You tell it everything, it helps you beautifully, and then the very next turn it's a total stranger all over again. That, at its core, is a raw language model. Every call starts from nothing because the model itself keeps no memory between requests. So how do the agents we actually rely on remember your preferences, pick a task back up from yesterday, and stay coherent across 100 steps? The answer is a memory system built around the model. Let's unpack how it works. So why can't a model just remember on its own? Here's the gap, laid side by side. A bare language model is stateless. Each time you call it, it only sees whatever you cram into that one prompt, and the moment the conversation ends or the window fills up, everything is gone. Can't recall what you told it an hour ago, let alone last week. So every single interaction begins from a blank slate. Agent memory fixes exactly that, carrying information across steps and sessions. Important facts, past interactions, and learned preferences get stored and pulled back in whenever they're relevant. So the agent builds on what it already knows. Suddenly, it can remember you, continue yesterday's task, and reason across far more than one crowded prompt. So how does a memory system actually work? It comes in layers and they hand information between them. Watch the loop. The recent conversation and the agent's scratchpad live in short-term working memory. This is simply what sits in the context window right now. The immediate back and forth the model can see this very turn. It's fast and always present, but it's also small and temporary, and it vanishes as the window fills. Anything worth keeping gets written to long-term memory, which lives outside the model entirely. Key facts, past events, and preferences are saved to an external store, very often a vector database, so they survive long after the current window has been flushed away and the chat has moved on. When a new turn needs one of those saved facts, the system retrieves it. It searches that external store for whatever is relevant to this moment and pulls just those pieces back, rather than dragging in everything the agent has ever seen. This is retrieval-augmented generation doing the real heavy lifting. Those retrieved memories then get fed back into the context window, right alongside the recent conversation. Now the model has both the immediate thread and the relevant history in front of it, so it can answer as though it genuinely remembers. Then the whole cycle repeats on the very next turn. Strip it all away and three ideas carry agent memory. Memory carries information across steps and sessions. Instead of restarting cold on every call, the agent keeps a thread of continuity running, so it can finish long multi-step tasks and recognize you the next time you show up. It works in layers. The recent context lives in fast short-term working memory, while important facts persist in a separate long-term store, frequently split into episodic memory for specific past events and semantic memory for general knowledge. Everything hinges on the context window limit. You simply can't stuff every fact into every prompt, since that's expensive and dilutes the model's attention. So the real craft is deciding what to store, what to retrieve, and what to summarize or quietly forget. Alright, let's lock in what matters. Agent memory is the set of systems that let an agent carry information across steps and sessions, instead of starting from a blank slate on every single turn. Because language models are stateless, memory splits into short-term working context and long-term storage, the latter often kept in a vector database and retrieved only when relevant. External memory is frequently divided into episodic memory for specific past events, and semantic memory for the general facts the agent has picked up along the way. The retrieval step is the real workhorse, using retrieval-augmented generation to pull the right memories into the limited context window without overflowing it. If you like AI ideas explained this clearly, a whole library of them is waiting for you at standarity.com. See you there.